Hello and welcome to section 3.6, which concerns square roots and the Pythagorean theorem. So here on this page I have listed some common squares. So remember, this square means that when you multiply a number by itself. Okay, so common squares would be 1, 1 squared is 1, 2 squared is 4, 9, 16, 25, and so on. 36, 49. I'm sure you guys have seen this before. 10 squared is 100. You have 121, 144, and 169 for 13. Now, to take a square root, so let's say if you think of the whole squaring function takes 11 to 121 because by squaring it, right? Well, taking the square root would take 121 back to 11. So if you were to take the square root of a perfect square, you get back to the number that you originally began. So it's kind of like saying if you have a square, then if I take the square root of both of these sides, I'll get back to where I started. So, square root of 1 would be 1, square root of 4 would be 2, square root of 9 would be 3, square root of 16 would be 4, square root of 25 would be 5, square root of 36 would be 6, square root of 49 would be 7, and so on. So that's kind of how it is here. So if you say so another way, putting it in a different way. So you can think of it as if the square root of a number is b, then that means that b squared is equal to a. So here you would say, see here, square root of 0 is 0, right? 0 squared is equal to 0. Square root of 1 is 1, right? 1 squared is equal to 1. And so you see that here. You can think of them as inverses in the sense of how multiplication and division are inverses. Addition and subtraction are inverse operations. That's kind of one thing you can think about. One action undoes the other, and so on. Okay, so that's what square roots are. Now let's do some. Let's go ahead and use some. So here we have 7 times square root of 64. That would be, square root of 64 is a perfect square, so that's 8, right? So then that would be 56. And then here you have square root of 9 plus square root of 16. So then that would just be 3 plus 4, which is 7. Okay? And then here, another property of square roots, you can do the square root of the top and the bottom when you're square rooting or taking the square root of a fraction, right? I don't know if square rooting is actually a word, that's why. So square root of 25 is 5, square root of 81 is 9, and there you go. Here, square root of 12 times the square root of 25, that would just be 12 times, and then the square root of 25 is 5, so that would be 60. Okay, here, 100 minus 6, square root of 100 minus the square root of 36 would be 10 minus 6, which is 4. Okay, and then the same thing here. Square root of 49, square root of 121, 7 over 11. So pretty simple if you have perfect squares, okay? So let's see if you can do some super fun. Now you try. So go ahead and push pause and then try to work these out on your own. This is the entire fraction. And then we will go over them together when you unpause. Okay, ready and pause. Okay, so welcome back. So this is 4 times the square root of 25. So 4 times 5, which is 20. Okay. And then you have square root of 36 plus the square root of 4. 6 plus 4 is 10. Okay, and then you have the square root of 36 over square root of 100. And I'm really hoping that you are taking advantage and pausing the videos and doing the examples that now you try on your own, because really the best way to learn mathematics is to do mathematics. So you should take any chance you get to practice. Okay, so we have 14 times square root of 36. That's just 14 times 6, which is 84. Okay, And then we have square root of 81 minus square root of 25, 9 minus 5, which is 4. And then we have here square root of 64 over square root of 121, which should just be 8 over 11. Okay, great. Okay, so now we're going to talk about approximations. Okay, so when you take the square root of numbers that are not perfect squares, so what if I want to take the square root of 7, for instance? 7 is not a perfect square because there are no two numbers that when you multiply them, it's 7. No two, whole numbers or, positive numbers, right? So positive whole numbers. So we have here, we have an approximation, okay? So you can check here and see how close it is to 7. So here, if you were to take the square root of 7 and approximate it to the nearest tenth, you would get 2.6. And if you square 2.6, you would get 6.76. So you see how it's not exactly 7, but you also see that the more decimals you have, the closer approximation you have, okay? And then the next question is, well, how do you get to these numbers? Well, we use the calculator to get to these numbers. I mean, you can kind of guess that it's in 2 because 7 is in between 4 and 9, right? And then square root of 4 is 2, square root of 9 is 3. So we already know that it's going to be in between 2 and 3. So let's go ahead and try some on our calculator. So how would we approximate 5 root 12 to the nearest 10,000? Well, first you have to calculate, I'm going to bring in my really cool calculator here. Okay, so I'm doing 5 and then the square root of 12, and it's going to give me some decimal, okay? So, 17.30, 0.305, and da-da-da, right? So it has a couple of things, but it says here we need to round to the nearest 10,000th. So that means it's going to be 10 hundreds, thousands, 10,000. So we're going to stop at the 5. Next to the 5 is a 0, so we keep it as a 5. So this is going to be approximately 17.3205. Okay. Now this is a calculator I downloaded on my phone. It's not too bad. Just you can go ahead and do that. But there's other ways you can do. You can, if you have a more simple calculator, you can just calculate the square root part first, then multiply that by 5, and then go ahead and round to wherever you need to. So in this case, they want the nearest hundredth. So I would go second square root 301, and then plus square root of 137. Okay. So then in this case, it says the nearest hundredth, so I'm going to go tens, hundredths place, it's a 5. Okay, so the next one, the one next to it is a 4, so we keep it there. So this is going to be 29.05, approximately. These little wiggly lines mean approximately. Okay, so now let's do this one. So second square root, let me quit that. Second square root, and we're doing a fraction, so 7 over 10. Or 7 over 11, sorry. How do I delete this? Oh no! Let me go ahead and try over. Second square root, and it's 7 over 11. Okay, and I need to make sure that it's underneath the radical, so it is. Okay, so, and then that's the nearest thousandth, so tens, hundreds, thousands. Now the thousands number here is 7, but the one right next to it is greater than 5, it's 7. So this needs to become an 8. Okay? So to the nearest thousandth, the number is 0.798. Okay? All right. So that is that for that. Okay, so here we go, Pythagorean theorem. What is the Pythagorean theorem? So for any right triangle, what's a right triangle? A right triangle is a triangle that contains an angle of 90 degrees. Okay, that's this here. It doesn't matter what these other two angles are. One of them just has to be 90 degrees. And here are the parts of a triangle. They're usually labeled ABC. This is a leg, this is another leg, and the longest side, which is the side across the right angle, is called the hypotenuse. hypotenuse. So we have to be familiar with this, okay, when you have a right triangle. Now, it's really cool because the history of the Pythagorean theorem, and in fact the Pythagoreans, it used to be almost cultish, you know, a long time ago when this was first discovered, you couldn't tell anybody about it. It was considered blasphemy or something, and they were like, I think it was like a secret. It was like this terrible secret that this, and it's so funny because it's commonplace now, but back then it was a big deal. Okay, so what is the Pythagorean theorem? The Pythagorean theorem says, given a right triangle, okay, if I take the distance of each leg and I square them separately, right? So I take this distance and I square it, and then I add it to this distance and I square it, that's going to equal the longest side squared. So it's nicely put, a squared plus b squared equals c squared, where a and b are the legs and c is the hypotenuse, okay? If I was to solve for c, I just take the square root of both sides and I end up with this, okay? So how would I find the length of the hypotenuse in each right triangle? For example, I would just plug it into the Pythagorean theorem. So it doesn't matter what a or b is, it just matters that c is c. So you would have 4 squared plus 3 squared is equal to c squared. So this would be 16 plus 9 is equal to c squared. This is 25 equals to c squared. To get rid of this square, I'm going to square root to both sides, right? This will cancel out because they're inverse functions. And this is a c, and this is 5. So 5 is equal to c. All right, let's do another one. So we have c squared, and then I'm going to write it in a different way, but it's the same thing, right, because of reflexive property. So I have here a squared plus b squared. So 5 squared plus 7 squared, that's going to be 25 plus 49. C squared is equal to 25 plus 49. And what is 25 plus 49? That's going to be 74. So c squared is equal to 74, but let's take the square root. Now we know. Okay, so c is equal to, and then what's the square root of 74? That's going to be 8.6 something. So we can go ahead and just leave it as 8.60 because we have 8.602, so it's 8.60, and oh, sorry, we need to keep the thing. So this is inches, and then this one was meters, so go ahead and put meters as your unit. When they're giving you a unit in a problem, you should keep it in the answer as well. Okay. Okay, finally, let's go ahead and try that. Now you try. Find the length of the hypotenuse of each right triangle. Round to nearest hundredth if necessary. Pause the video, try this out, and then we will do this together. Okay, here we go. So a squared plus b squared is equal to c squared, right? The legs, squares of the legs added together is equal to the hypotenuse squared. So this is 25 plus 25 is equal to c squared. I'm going to rewrite the c squared in front. C squared is equal to 50. Then I take the square root, right? I'm only using positive because positive, it's a positive distance, so I know that it's going to be positive. Technically, when you square root a square, it could be positive or negative, and we'll talk more about that later, but for now this is okay. For now we just keep it positive, okay? Because we're talking about distances. We don't have negative distance. Alright, so what is the square root of 50? Okay, it's going to be 7.07 feet. Okay, so that's that one. Let's do the next one. We have c squared is equal to 12 squared plus 16 squared. Okay, and then you can just put c is equal to, and then the square root of, oh well, let's go ahead and first do this. So this is 144 plus, and then 16 squared is 256. So add it together, 256 plus 144 is 400. C squared is 400. That's nice. That's a perfect square. Take the square root. That's going to be 20. Okay, 20 centimeters. Okay. So just because you're doing a square root of a square, make sure that you understand this is positive. But Later on, we're going to talk about the negative case, okay? All right, so that's it for 3.6. Good luck, and I will see you in the next video.